Hello, I'm Medha Parlikar, the CTO and one of the co-founders of CasperLabs, the builders of the Casper protocol. Firstly, I'd like to thank Draper Goren Holm for hosting LA Blockchain Summit and inviting me to speak to you today. I hope to inspire you to think about blockchain projects differently. I will take you to a world beyond the smart contract platforms that exist today and into larger application architectures. The next generation of enterprise blockchain projects won't have to play a balancing act between security, scalability, and decentralization. Before we dive in, I'd like to share a bit about my story. Prior to getting involved in the space, I spent the past 2 decades at marquee software companies as a technical leader, responsible for quality and core product delivery. I was responsible for delivering robust, reliable SaaS software and was accountable to business stakeholders for uptime, features, and customer satisfaction. I was entrusted to make technical product decisions for the company on a daily basis. We are here today because we believe that blockchain can be a quantum leap for business software. I started Casper because I knew that blockchain could transform industries. As we built Casper, I learned that the technology in the market does not meet the basic requirements that I had in my own decision-making around selecting a technology platform. So we set out to build a protocol and platform that met these requirements. Today, I'll walk you through 4 ways Casper solves key business problems more simply than any other blockchain solution in the market, and talk about one massive company already working with us to transform their business right now. Our team is steeped in experience of building enterprise-grade software that fuels business. This is just a small sampling of some of the companies our core dev team has experience with, and I hope by the end of this talk, you'll walk away inspired to start building with blockchain for your business. Blockchain has huge potential to give an edge in the marketplace to companies that adopt it. But when selecting a trust layer, or any technology upon which you will build your business for that matter, you need to have one that supports your needs today, but even more importantly, in the future as your business grows. We have had a great run so far, but true adoption has to go beyond tokens. There are so many more problems that blockchain could solve for us. Let's dive into the essential components of a business application and how blockchain technology could fit in. Blockchain shouldn't be implemented for its own sake. When we think about this technology, we need to ask ourselves if there's a real business benefit to adding a layer of trust. There are existing applications and processes that solve the problem of provenance and traceability, but they use agencies and centralized control to achieve trust. They're also error-prone as a result and are very expensive, both in real cost and time to market. The question to ask is, does the product or service benefit from a trust layer? Or are your operations more efficient as a result of a trust layer? If the answer is yes, then blockchain can make sense for your solution. Here are some great examples. Did you know that 5 to 10% of all patents that are sold today are sold by someone that doesn't actually have the right to sell them? Public blockchain can help enforce contract compliance and reduce waste and fraud, intentional or unintentional fraud, just by tracking the provenance of these patent data. Content creators and authors don't have visibility into the accuracy of their royalty payments. They don't know who's been interacting with their content at a real granular level and how payments are actually calculated and divided up between the many people that contribute to a given piece of content. And pharmaceutical companies spend almost double the amount of time validating their clinical trial data compared to actually collecting the data set itself. And just imagine the impact we could have with bringing new and wonderful life-saving technologies to market by shortening the amount of time we need to evaluate clinical trial data. In all of these cases, the blockchain just brings trust to the data. So now let's dive into the essential pieces of an application. There are 4 core user stories that you will need a compelling answer for in order to build a business using software. You got to acquire users and you have to support them. You have to accept payments and apply them toward the use of the product or service that you're offering, or else you aren't going to make any money. You have your core logic, which is your unique value proposition. You have the data you're going to store, either on-chain or off-chain. And there's going to be some reporting that you'll need, either KPIs to run your own business, or your users are going to ask for reports. You will need to administer all of these pieces, and you'll also need to upgrade the entire application and system, including your smart contracts. And so now let's dig into each functional area. Let's start with user accounts. You can't have a business without users. And depending on what your application does, you may need a basic notion of accounts or something more complex like self-sovereign identity, as we learned about today. Since we're talking about blockchain, this means keys and the management of keys and the administration of keys. And we know we want users to retain control of keys because this is very important in order to maintain decentralization. All of these layer ones have different stories for user accounts. They use different encryption types, and all in all, it's very confusing. They do have one thing in common though, and that's the terrible user story for lost keys on most of the layer 1 protocols in this space today. And so what are the alternatives? Your application takes the responsibility for keys. Accounts are hugely important, both for your own internal administration of contracts and accounts, but for your users as well. And you don't want to be outdone by a competitor that offers better customer service or has a better user experience. It would never be reasonable for me to inform my stakeholders that we can't recover accounts or passwords or support our customers. I know that account management is essential for business, so we built this directly into the protocol. We support multiple key types to reduce cross-chain user account friction, account delegation, and a powerful permissioning structure. A platform should provide core capabilities which enable developers to create features. With these core capabilities, you can build, your developers can build the capability to recover accounts through social recovery tools on chain. They can govern the protocol, and you can support your customers by letting your customers grant access to their account or their contract state. And you can build features for your customers where they can themselves have complex account management features within your application if you want to build something complex like Salesforce, for example. And even though you may not need these features today, you don't know that you're not going to need them in the future, and you want to be sure you're covered in the case you're wildly successful. So how about payments? I mean, the blockchain is all about payments and tokens, right? You obviously need to pay for the use of the blockchain. You want your users to sign transactions in the chain because that provides the history and proofs that you want. And for this, they have to be in control of their keys. So let's take a look at how this works today on most of the smart contracting platforms. Today, if you want to use blockchain in your system, it's your user's problem to pay for the contract execution. This is the actual workflow that users go through with Ethereum. This platform interface bleeds into your application, and it shouldn't do this. Forget about being future-proof. This isn't even easy to use. And this isn't a system that is going to give you the control you need to grow your business. Just imagine integrating this workflow into your application UX. So imagine telling your users to go find an exchange and buy some token right before you get started. And make sure you put it in the right account. Otherwise, it's not going to work in the app. And then just think about what this is going to do for your conversion funnels for customer acquisition. What you really want is the flexibility to design whatever kind of payment rails you want. Users shouldn't have to care about the blockchain at all. Remember, we still want users to retain control of their identity, keys, and transactions. We want to know for certain that I signed a transaction with my key that I held in my possession. This is why we built the rails to support flexible payments. Flexible payments will let you create whatever kind of payment mechanism your business needs. You can choose to pay for your users' on-chain transactions, and the user still signs the transaction with their key. And you can also create advanced payment options to meet future billing requirements as your business needs change. So now let's talk about the core of your application logic. Since this is a blockchain conference, I'm going to focus on smart contracts. The space today is riddled with brand new programming languages and developer tools to help make smart contracting authoring easier. None of these tools give any freedom to select the tooling and workflow that you need to ship features, because in the end, you have to ship features fast, and you got to hire and retain staff to build these features for your business. For sure, when I selected my platform and applications, the skills of my team, compatibility with existing tool chains were huge considerations. I wasn't going to pick a brand new programming language that nobody on my team knew how to use. So what did we do? We decided to create a platform that used existing programming languages and open standards, starting with Rust, AssemblyScript, and WebAssembly. We adapted our protocol to integrate fully into existing development processes. And while there are several protocols that support multiple programming languages for smart contract development, like Rust, Casper does something really unique. Casper gives you a contract runtime and a blockchain store that runs locally on any machine. So you ask, why is this important? Well, imagine you have a large application architecture that's going to send data to the blockchain. And you've created this application using a bunch of tools and languages. Maybe you're using IntelliJ or CLion, or you want to use Visual Studio to build your application. Well, the blockchain platform needs to work within your product, not the other way around. So what you want to be able to do is drop in the blockchain architecture, the blockchain technology, into the tooling that you use to build your application. And here you can see that on the screen, there's some assertions on whether my contract was set up correctly. And so what's really cool is I can initialize the blockchain before I run my application all on my computer. And this is really, really important for developers because they can test all their code using the tools they already have all on their local machine. So for the many decades I've been doing this, in my organizations, anyone that committed buggy code to the repository heard about it, right? Their bug would halt the pipeline and stop builds. And this is the same thing as halting the assembly line when you're manufacturing equipment. And as the product owner, you want to give your customers guarantees that you've tested your code. And from a best practices perspective, these tests need to be run on every single code change that is made in the system. This is something I've had to assure for many years in go or no-go release meetings. With Casper, you can be rest assured that you can use blockchain without having to upend your tooling or hire a bunch of special talent. Building an application that fuels a business requires that your application is maintained and upgraded. Let's dig into how this core requirement could be supported. So meet the proxy contract. This is very popular in Ethereum today because a lot of blockchains like Ethereum don't let you upgrade contracts. So what authors do instead, as a best practice, is create a pointer to a version of the contracts. This is a hack that's a workaround to a basic missing piece of platform capability, and that is to maintain the on-chain code. So what are the problems with this architecture? Well, your data and logic are separated instead of being stored together. And in my opinion, this is not what you want in public or shared infrastructure. The older version of the contract isn't really gone. It's still there, and someone can call it. And in the event of a protocol fork, your on-chain code will exist in both versions of the blockchain. So basically, once you put your code out there on the blockchain, you basically relinquish all control to it. And I would never take this kind of dependency on for a mission-critical application. And this is one of the reasons why a lot of enterprise companies are looking to private blockchain, because they need this full control. And what we really want is to maintain our on-chain code, keep the data associated with our logic together, and we need to control how and when we upgrade our on-chain contracts. And so software is packaged today. We're very used to this paradigm. So why not on the blockchain? So we went ahead and we built this too. We built a comprehensive story around contract packaging and management. Contract owners can deploy a contract package that specifies how the contracts in the package will behave and how they will be upgraded. It's possible to specify a protocol version, and when you deploy a new version of the contract, the system will version your contract for you. And you can manage which version of the protocol your contract works with, and you can also kill old versions of your contracts. This gives you full control over your on-chain code, and you can do this all on a public, permissionless blockchain. Now that we've talked about being able to create contract packages and upgrade contract packages, let's talk about how contracts actually fit into the broader application delivery pipeline. So how do we get these updates in? So your application will be delivered via existing development operations tools. With the protocols out there today, the blockchain tooling doesn't work with existing DevOps ecosystem tools. So it's going to be this one-off snap-on, and the contracts will be tested in a petri dish, disconnected from the rest of the system. To resolve this issue, you can choose the following. You can push your entire DevOps pipeline into the cloud that provides blockchain DevOps, and you won't get to pick any which one you want. It's going to be those cloud providers that provide DevOps for the blockchain you selected. You can choose to run a full blockchain node in your pipeline, or you can pay gas fees and run your contracts occasionally in test nets at some interval. And all of these options are going to be both expensive and time consuming, and they still are not going to give you the results that you want. This is not an architecture or option I would ever propose to my stakeholders. And so this is what your pipeline is going to look like. It's not going to be very efficient or easy to maintain. And you can definitely see here it's not integrated, barely integrated. So you're going to see bugs drip through in the middle. And rather spending time building your business or great idea, you're going to be messing with your infrastructure. And this is not the kind of infrastructure that's going to help you win. And this is how your developers will feel. Too many sad pandas. Again, you want to build your contracts alongside your application. So with Casper, all you need is 4 lines, and Casper Contracts will build and run alongside your application in the existing DevOps ecosystem. This will work with any instrumentation that you currently use, and any developer can set this up without needing any special skills. This is possible because we provide you a VM and internal blockchain state store to you as a small runnable component that will run on any Linux machine. We created this tool for our own purpose because we saw that we needed this tooling to develop smart contracts with confidence. And now we're making this tool available to anyone that wants to build on Casper. And in almost every organization where I have worked, the first problem I was tasked to solve was around this DevOps pipeline. Having a solid pipeline is absolutely critical to quality software delivery. And I would never, ever select a platform that risked my DevOps pipeline. When you provide all these core features coupled with the trust of decentralized permissionless public blockchain, it's possible to unlock the potential of the trust layer. Next, I will dig into a real world use case that's implementing Casper. IPWe created the first platform for the world's patent ecosystem, connecting buyers and sellers of patents and patent-related services, creating a tradable asset. They leverage the power of artificial intelligence, data mining, and predictive analytics to unlock a global patent value, and have created entirely new ways of interacting and transacting with patents. They are also a gold member of IBM Global Blockchain Service, and our prototype will demonstrate the power of Casper contract management with respects to patent data. They selected Casper for the following reasons. We provide real decentralized consensus and the security required to prove patent ownership, smart contract capability that helps manage and enforce contract compliance, and powerful account features which simplify the blockchain interoperability requirements in their architecture. We'll be going live with our IPWe implementation in 2021, shortly after our mainnet launches. When you make the right choice of the platform to leverage, you can get the best of what blockchain has to offer without the baggage. And this is what you need if your big idea is going to win. You can build solutions that don't require anything new, because the protocol snaps right into the architecture. And you don't need to wait until your product or application has millions of users to switch to the right layer 1 platform. You can make the right choice today and capture the competitive advantage that blockchain can bring. Blockchain presents the opportunity to streamline operations across many industries by adding a layer of trust and guarantees in multi-party operations. The technology curve is exponential, so there's a significant risk of falling behind if you aren't thinking a generation ahead. As we grow to Web3, the decisions that everyone makes, from developers to CTOs, will decide the winners and losers of tomorrow. If you're interested in learning how you can benefit from blockchain in your application architecture, feel free to reach out to us. We look forward to building the decentralized future with you together. Thank you for your time and attention.